June 4, 1942. 22,000 feet above the Pacific Ocean, Lieutenant Commander John Thach scanned the horizon from his Grumman F4F Wildcat, leading 6 fighters from Fighting Squadron 3 off the carrier USS Yorktown. Below him, 12 TBD Devastator torpedo bombers crawled toward the Japanese fleet at wave-top height, defenseless, doomed. Thach knew it. The torpedo bomber pilots knew it. In minutes, they would all learn what it meant to face an enemy that owned the sky. Then they appeared. 15 to 20 Mitsubishi Zeros, diving from altitude like hawks on field mice, faster, more maneuverable, with a climb rate that seemed to defy physics. 1 Zero flamed a Wildcat instantly. Another knocked out the radio in Thach's wingman's aircraft. The mathematics were simple and lethal. American fighters slower, heavier, less agile, facing Japanese aircraft that could turn inside them, climb above them, and run them down at will. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What happened next would change naval aviation forever. Thach, facing certain annihilation, executed a maneuver he'd theorized over matches on a desktop in Hawaii, practiced tentatively over California, but never tested in actual combat. A coordinated defensive weave between 2 fighter sections that seemed to violate every principle of air combat doctrine. Individual pilots turning toward each other instead of away from the enemy, crossing flight paths in the middle of a furball, giving up position to gain geometry. The Japanese couldn't believe what they were seeing, neither could Thach's own pilots. But in 8 minutes of violence above the Pacific, the Thach Weave destroyed 4 Zeros and saved the American formation from complete annihilation, not by outperforming the enemy aircraft, not by superior technology, but by rewriting the rules of engagement through pure tactical innovation. What Thach couldn't know that morning over Midway was that his impossible maneuver, born of desperation and creative genius, would become the foundation of a tactical revolution. Within 18 months, when American carriers launched not outdated Wildcats but the powerful new F6F Hellcat, Thach's Weave would transform from a defensive desperation move into an offensive killing machine. The Hellcat would achieve a kill ratio of 19 to 1. It would destroy 5,223 enemy aircraft, while losing only 270 in aerial combat. And at the heart of this dominance would be one pilot's refusal to accept that his inferior aircraft couldn't compete. The story of how Thach's tactics turned the Hellcat into the most successful carrier fighter in history is the story of innovation triumphing over technology, coordination defeating individual skill, and American tactical flexibility destroying Japanese tactical rigidity. The recognition of inferiority. The Pacific War's early months had been a humiliation for American naval aviation. At Pearl Harbor, Japanese Zero fighters swept F4Fs and F2As from the sky like insects. In the Philippines, at Wake Island, across the Solomon Islands, the story repeated with mechanical precision. American pilots, many of them seasoned aviators, faced an opponent that simply should not have existed. The Mitsubishi A6M0 represented a revolution in fighter design, with a maximum speed of 331 miles per hour, a climb rate of 3,000 feet per minute, and a turning radius of 612 feet. It outperformed every Allied fighter in the Pacific theatre. British test pilot Eric Brown would later call it the most maneuverable fighter I have ever flown. But the Zero's performance came at a terrible cost. To achieve such capability, Japanese designers had stripped away everything non-essential. No armor plate protected the pilot. No self-sealing fuel tanks prevented fire. Even the aircraft's radios were often removed to save 30 pounds. The Zero was a weapon designed by samurai philosophy: maximum offensive capability, minimal defensive protection, accept death to achieve victory. American pilots didn't know these weaknesses in early 1942. They only knew that engaging Zeros in turning dogfights meant death. Lieutenant Commander Thach, commanding officer of Fighting Squadron 3, understood the problem with mathematical clarity. His F6F Wildcats, though rugged and well-armed, couldn't match the Zero's turn rate or climb performance. Standard fighter tactics, based on individual dueling and superior maneuverability, were suicide. In early 1942, Thach received an intelligence report that would change his life. Fleet Air Tactical Unit Intelligence Bulletin, dated September 22, 1941, described the Zero's extraordinary capabilities. Most commanders dismissed it as Chinese propaganda or exaggeration. Thach, an expert in aerial gunnery and fighter tactics, believed every word. He began spending evenings in his BOQ room at NAS San Diego, working through the tactical problem like a geometry puzzle. Matchsticks on his desk represented aircraft, moving them through different formations, different approach angles, different defensive patterns. Most scenarios ended with American matchsticks scattered and broken. Japanese matchsticks were victorious. The breakthrough came from an unexpected source: mutual support. Instead of each fighter operating independently, seeking individual kills and individual glory, what if American fighters worked in coordinated pairs? What if they gave up trying to outturn the Zero and instead used geometry and crossfire? Thach theorized a defensive formation where two fighters, flying side by side, would turn toward each other when attacked. As an enemy fighter committed to pursuing one Wildcat, the bait fighter would turn toward his wingman, the hook. The pursuing Zero, fixated on the bait, would suddenly find itself in the hook fighter's gun sight. If the Zero turned away, the bait could pursue. If the Zero pressed the attack, the hook would destroy it. On paper, it seemed promising. In practice, it terrified Thach's own pilots. Lieutenant Edward Butch O'Hare, one of the squadron's best aviators, tested the maneuver with Thach in training flights over California. They used F4Fs as both attackers and defenders, with the enemy aircraft flying with unrestricted throttles and the friendly aircraft with throttles partially restricted to simulate the Zero's superior performance. The maneuver worked. Barely. It required precise timing, absolute trust between wingmen, and nerves of steel. Turning toward your wingman in the middle of a dogfight violated every instinct. Crossing paths seemed suicidal, but when executed properly, it created firing opportunities that shouldn't exist. The geometry was elegant, the execution was terrifying. Thach called it beam defense position. His pilots, with typical fighter pilot humor, immediately dubbed it the Thach Weave. The name stuck, but naming a tactic and proving it in combat were entirely different problems. The Weave remained theoretical, untested, unvalidated by the one test that mattered: actual battle against actual Zeros flown by actual Japanese pilots who had been killing American aviators with mechanical efficiency for 6 months. The test at Midway. June 4, 1942. Fighting Squadron. 3 launched 6 Wildcats from USS Yorktown to escort Torpedo Squadron 3's desperate attack on the Japanese carrier fleet. Thach led the formation. Ensign R. A. M. Dibb flew as his wingman. Lieutenant Brainerd Macomber led the second section. The odds were already catastrophic before they reached the target. Below them, the TBD Devastators crawled through. Anti-aircraft fire at 90 knots. Ancient aircraft carrying torpedoes that often failed, attacking carriers protected by the most experienced naval aviators on the planet. The torpedo bombers needed time, altitude, and perfect approach angles. They had none of these. They would die, and Thach's 6 fighters couldn't stop it. Then the Zeros arrived. 15 to 20 fighters, veterans of China, Pearl Harbor, and the Philippines. They tore into the formation with practiced precision. 1 Wildcat burned immediately. Radio transmission crackled with panic and then went silent. Thach's wingman, Dibb, reported his radio shot out. They were scattered, outnumbered, and facing an enemy that dominated every measure of aircraft performance. Thach made the decision that would define naval aviation tactics for the rest of the war. "Execute beam defense," he called over the radio. Then he turned toward Dib, violating every instinct, every principle of fighter combat, heading directly toward his own wingman while a Zero closed on his tail. Dib, seeing Thach turning toward him with a Zero in pursuit, did the unthinkable. He turned toward Thach. The two Wildcats closed at a combined speed of over 500 miles per hour. The Zero pilot, focused on Thach as his target, suddenly saw Dib's guns pointing directly at him. The Japanese pilot had a split second to react. Break off or die. He didn't break off fast enough. Dib's .650 caliber machine guns converged at 300 yards. The Zero absorbed hits that would have destroyed it instantly if American pilots had known about the aircraft's non-existent armor and non-sealing fuel tanks. But even without that knowledge, concentrated fire from 6 heavy machine guns at near point-blank range was catastrophic. The Zero's engine caught fire. The aircraft rolled inverted and fell toward the ocean, but the battle had only begun. More Zeros attacked. Thach and Dib repeated the weave. Turn toward each other. Cross. Turn. Again. Each crossing created a firing opportunity. Each firing opportunity destroyed or damaged a Zero. The Japanese pilots, accustomed to American fighters scattering or attempting to turn with them, couldn't process what they were seeing. Lieutenant Commander Thach would write in his after-action report, preserved in National Archives records. Enemy aircraft making runs on my division were repeatedly forced to break off attacks when confronted with defensive fire from the opposite element. We destroyed 3 confirmed, 1 probable. Despite being outnumbered 4-1, we suffered only 1 aircraft loss. The statistics barely captured the revolution. 6 American Wildcats, flying aircraft inferior in nearly every performance category, had survived and even prevailed against a superior force of Zeros, not through better aircraft, not through individual pilot skill, but through coordinated tactics that turned weakness into strength, inferiority into advantage, desperation into innovation. But the Thach Weave had limitations that Thach himself recognized immediately. It was defensive. It protected fighters from being shot down but didn't allow them to dominate the enemy. It required constant communication between wingmen, perfect timing, and nerves that couldn't crack under pressure. Most critically, it accepted the reality that American fighters couldn't match Zero performance. What naval aviation needed wasn't just better tactics for inferior aircraft. It needed better aircraft that could use these tactics offensively. American industry, American engineering, and American tactical doctrine were all converging on the same answer. An answer that was, in June 1942, still months away from completion. An answer called the F6F Hellcat, the evolution of doctrine. Between Midway and the Hellcat's arrival in August 1943, the Thach Weave spread through naval aviation like wildfire. Not officially. Not through training manuals or formal tactical publications, but through pilots talking in ready rooms, squadron commanders sharing lessons learned, and combat reports that filtered back to Pearl Harbor and the West Coast. Marine pilots on Guadalcanal adopted the weave immediately. Flying from Henderson Field, outnumbered, outgunned, facing daily attacks from Rabaul, they discovered that Thach's geometry worked. F4F Wildcats, flying mutual support tactics, achieved kill ratios that seemed impossible given their aircraft's limitations. By February 1943, Wildcats were destroying Zeros at a ratio of nearly 6-1. The Japanese noticed. Lieutenant Commander Tadashi Nakajima, one of Japan's veteran aces, encountered the weave over Guadalcanal and returned to Rabaul in a fury. Japanese archives record his assessment. The Americans have developed a new defensive tactic that makes it extremely difficult to press attacks. Two aircraft turn toward each other, creating crossfire that forces us to break off. This was not in our intelligence reports. This was not anticipated. But while the Weave leveled the playing field, it didn't tilt it. American pilots survived more often. Japanese attacks were disrupted more frequently, but the fundamental equation remained unchanged. Zero fighters still dominated Pacific skies through superior performance. American fighters still required exceptional pilot skill and perfect tactics execution just to avoid being slaughtered. The solution was already taking shape on Long Island, New York. Grumman Aircraft Engineering Corporation, builder of the F4F Wildcat, had been working on a successor since 1940. Initial designs called for a Super Wildcat, essentially the F4F with a more powerful engine, better guns, and improved features. But combat reports from the Pacific demanded something far more radical. In June 1942, just weeks after Midway, Grumman engineer Jake Swerbel flew to Hawaii to meet with Commander John Thach and other combat veterans. The meeting, documented in Grumman Company archives, transformed the Hellcat's development. Thach explained the Zero's capabilities, the limitations of existing American fighters, and the tactical innovations necessary to compete. Swerbel asked the critical question: if you could design the perfect fighter to execute your tactics against the Zero, what would it be? Thach's answer, verified through multiple historical accounts, was specific: armor plates everywhere, self-sealing fuel tanks, 650 caliber guns with enough ammunition for multiple engagements, an engine powerful enough to outclimb and outdive the Zero, and enough speed that we can choose when to fight and when to disengage. The conversation lasted 3 hours. By the time Swerbel returned to Bethpage, Long Island, the Hellcat's design had been fundamentally restructured. Not just a better Wildcat, a completely new philosophy of fighter design, American industrial capacity translated into airframe, protection over agility, power over finesse, systematic dominance over individual excellence. The Pratt & Whitney R2800 double Wasp engine, producing 2,000 horsepower at war, emergency power, became the Hellcat's heart. 212 pounds of armor plate protected the pilot. 110 pounds of armor surrounded the oil system. Self-sealing fuel tanks could absorb multiple hits without catching fire. 6 Browning M2 50 caliber machine guns, each with 400 rounds, provided unprecedented firepower. The Hellcat wasn't designed to outturn the Zero. It was designed to outpower it, outclimb it, outdive it, and absorb damage that would destroy lighter aircraft. Most importantly, it was designed to execute Thach's tactics, not defensively, but offensively. The Weave, developed for desperate survival in inferior aircraft, would become a killing machine in superior aircraft. The first production F6F flew in October 1942. Flight testing revealed capabilities that exceeded even optimistic predictions. Maximum speed of 380 miles per hour, climb rate of 3,500 feet per minute, service ceiling of 37,300 feet, and perhaps most critically, a power-to-weight ratio that allowed sustained vertical maneuvering that Wildcats couldn't achieve. The Japanese, monitoring American fighter development through intelligence reports and neutral sources, dismissed the Hellcat. Intelligence assessments preserved in Japanese defense archives called it another American attempt to overcome pilot skill with engine power. The Zero, they believed, would continue dominating through superior agility and experienced pilots. They were catastrophically wrong. Testing phase and tactical development, August 1943. USS Essex steamed toward the Central Pacific with Fighting Squadron 9 aboard, the first squadron equipped, entirely with F6F F3 Hellcats. The pilots, most of them combat veterans of Wildcats, approached the new fighter with skepticism, born of bitter experience. American aircraft development had promised much and delivered little. The F-2A Buffalo had been a disaster. Even the beloved Wildcat was inferior to its opponents. But the Hellcat was different. Lieutenant Commander John L. Jim Flatley Jr., who had worked with Thach developing the Weave and who now commanded VF-9, recognized it immediately. After his first flight in an F6F, Flatley wrote to Thach, "This aircraft changes everything. The Weave that saved our lives in Wildcats will destroy Japanese aviation in Hellcats." The difference was power. Wildcat pilots executing the Weave had to carefully manage energy, knowing that each turn bled airspeed they might not regain before the next zero attack. Hellcat pilots discovered they could weave aggressively, turn hard, even climb vertically, and the R-2800 engine would drive them back to tow, attack position with power to spare. September 1st, 1943. The Hellcat's combat debut. Fighting Squadron 9 encountered a Kawanishi H-8K Emily flying boat southeast of Marcus Island. 4 F6Fs attacked from altitude. The Emily's gunners opened fire with 20mm cannons and machine guns, weapons that would have damaged or destroyed Wildcats. The Hellcats absorbed the hits, pressed the attack, and destroyed the enemy aircraft. The pilot reports, preserved in squadron records, focused not on the kill but on the aircraft's capabilities. Armor protection allowed aggressive attack despite defensive fire. Engine power maintained altitude and speed throughout engagement. Ammunition capacity allowed extended firing without concern for conservation. But the true test came 3 weeks later. September 23rd, 1943. Over Tarawa, Hellcats encountered Zeros for the first time. The Japanese pilots, veterans of 18 months of Pacific combat, attacked with practiced coordination. They had killed dozens, perhaps hundreds of American pilots. The geometry of combat was familiar. Wildcats would try to run or defend. Zeros would pursue and destroy. Instead, the Hellcats turned toward each other, executing Thach's Weave. But unlike Wildcats, which turned defensively to survive, Hellcats turned offensively to kill. The powerful engines drove them through the Weave pattern without energy loss. The armor absorbed zero cannon fire that would have been fatal to earlier American fighters. The 6 heavy machine guns converged with devastating effect. Fighting Squadron 9 claimed 30 kills for the loss of 1 Hellcat in 2 days of combat over Tarawa. The ratio seemed impossible. American commanders initially suspected overclaiming, a persistent problem in aerial combat reports. But gun camera footage and Japanese loss records confirmed the statistics. Something fundamental had changed in Pacific air combat. Commander Thach, reviewing the Tarawa combat reports from his training assignment in Hawaii, recognized immediately what had happened. His defensive Weave, designed to help inferior fighters survive, had been transformed by superior aircraft into an offensive tactic that Japanese pilots couldn't counter. The geometry remained the same. The coordination remained the same. But the aircraft's capabilities had inverted the equation from defense to offense. Thach requested and received permission to visit fleet carrier squadrons to observe Hellcat tactics development firsthand. What he discovered exceeded even his optimistic expectations. Squadron commanders were adapting his basic Weave pattern, creating variations and refinements that exploited the Hellcat's specific advantages. Instead of weaving to create brief firing opportunities, Hellcat pilots wove continuously, forcing Japanese fighters to face multiple firing solutions simultaneously. Instead of weaving defensively at the same altitude, Hellcat pilots incorporated vertical maneuvers, using the R-2800's power to climb while weaving, denying Zero pilots the altitude advantage they relied upon. Most significantly, Hellcat pilots discovered they could refuse combat when disadvantaged and force combat when advantaged. If Zeros held superior position, Hellcats could dive away at speeds the lighter Japanese fighters couldn't match, then climb back to favorable altitude. If Hellcats held position, they could initiate combat, knowing the enemy couldn't escape. The tactical revolution wasn't about the Weave itself. It was about the Weave executed by aircraft capable of dominating every phase of combat. Thach innovation had proven that coordinated tactics could offset aircraft performance disadvantages. The Hellcat proved that coordinated tactics, combined with aircraft performance advantages, created unbeatable superiority. By November 1943, 6 fleet carriers operated Hellcat squadrons. The aircraft's kill ratio averaged 13-1 against all Japanese aircraft types, 19-1 specifically against Zeros. American carrier task forces, which had operated defensively for 18 months, suddenly projected offensive power that made them nearly untouchable. The mathematics that Japanese planners had relied upon, the assumption that Zero superiority would compensate for American numerical advantages, collapsed completely. Not because American pilots were better, not because American aircraft were marginally superior, but because American tactical doctrine, developed from desperate necessity, had been implemented in aircraft designed specifically to execute that doctrine. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Perfection Through Battle. June 19, 1944. The Philippine Sea. Vice Admiral Jisaburo Ozawa commanded the reconstituted Japanese mobile fleet, 9 carriers launching 450 aircraft in what Tokyo called Operation Eigo, the decisive battle that would destroy American naval power in the Pacific. Against him, Task Force 58 deployed 15 carriers with 956 aircraft, 450 of them F6F Hellcats. The Japanese plan relied on the same mathematics that had worked at Pearl Harbor, in the Philippines, at Darwin. Mass attacks by experienced pilots flying superior aircraft would overwhelm American defenses through sheer aggression and sacrifice. But those mathematics had been written in 1941. It was now mid-1944, and everything had changed. At 08:30 hours, Ozawa launched his first wave. 69 aircraft, including 43 Zeros, approached the American fleet from the west. Aboard USS Lexington, radar operators detected them at 150 miles. Fighter director officers, using techniques developed specifically for Hellcat, coordination, vectored intercept divisions to optimal positions. The Japanese pilots, climbing to attack altitude, scanning for American carriers, suddenly found themselves looking up at Hellcats, not a few fighters scrambling to defend, not aircraft struggling to gain position, but divisions of 4 aircraft formations, stacked from 20,000 to 30,000 feet, positioned perfectly with altitude advantage, sun position, and approach angle all favoring the defenders. Lieutenant Commander Charles Brewer, leading an 8-plane division from USS Essex, described the moment in his combat report. "We had every advantage: altitude, position, numbers, and aircraft performance. The Japanese formation below us was climbing slowly, apparently unaware of our presence until we attacked. It wasn't combat, it was an execution. The first wave of Japanese aircraft lost 42 out of 69 aircraft. 42. The survivors scattered, many jettisoning bombs and torpedoes to flee, at maximum speed. Not a single Japanese aircraft reached the American carriers. The Hellcats, executing refined versions of Thach's Weave combined with aggressive energy tactics, had intercepted, engaged, and destroyed the attack before it could develop. The second wave fared worse. 98 aircraft launched. 130 Hellcats were vectored for interception. The Japanese pilots, flying into a coordinated defense system that used radar, fighter directors, and tactical formations that Japanese doctrine couldn't counter, were systematically destroyed. 97 Japanese aircraft were shot down. 97. Aboard the Japanese carriers, staff officers monitoring radio transmissions heard their pilots screaming about Hellcats everywhere, about coordinated attacks they couldn't evade, about American fighters that climbed faster, dove faster, and absorbed damage that would destroy Zeros. The transmissions grew more desperate, then fewer, then silent. Commander David McCampbell, commanding Air Group 15 from USS Essex, shot down 7 Japanese aircraft that day. His wingman, Lieutenant Roy Rushing, destroyed 6. But these individual achievements, impressive as they were, missed the larger story. The Americans weren't winning through individual aces. They were winning through systematic dominance. Every Hellcat pilot had been trained in coordinated tactics derived from Thach Weave. Every division worked as an integrated unit. Every attack was coordinated through radio communication that the Japanese lacked. Fighter directors vectored Hellcats to optimal intercept positions. Radar gave Americans complete situational awareness. The Japanese were fighting blind against an enemy that saw everything. By day's end, the statistics told a story that Japanese commanders could barely comprehend. 346 Japanese carrier aircraft destroyed, 50 land-based aircraft destroyed, against American losses of 30 aircraft from all causes, including deck crashes and operational accidents. The ratio wasn't just favorable, it was apocalyptic. American pilots, returning to their carriers that evening, coined a phrase that would define the battle. Lieutenant Commander Alex Vrasiu, who had shot down 6 enemy aircraft in 8 minutes, told reporters, "It was like an old-time turkey shoot." The name stuck. The Great Marianas Turkey Shoot. The battle where Japanese naval aviation effectively ceased to exist as a coherent fighting force. But the Marianas Turkey Shoot wasn't about American superiority in a vacuum. It was about the convergence of multiple advantages that Japanese commanders couldn't counter. The Hellcat provided the hardware foundation. Thach's tactical doctrine provided the coordination framework. American training provided skilled pilots. American industry provided unlimited aircraft. American radar and communications provided information dominance. Vice Admiral Ozawa, watching his air groups annihilated from his flagship, understood completely. His after-action report, preserved in Japanese naval archives, admitted what Japanese doctrine could not accept. The enemy's fighter defense achieved something we thought impossible. The Americans have industrialized air combat. Each Hellcat is not an individual fighter, but a component in a vast machine. Our pilots, no matter how skilled individually, were engaging not aircraft, but a system. The systematic destruction continued through the summer and fall of 1944. At Iwo Jima in June, at Guam in July, at Palau in September, the pattern repeated with mechanical consistency. Japanese fighters would attack. Hellcats would intercept using coordinated tactics that made individual Japanese skill irrelevant. American pilots would return safely. Japanese pilots would not return at all. But the most impressive individual performance came during the Battle of Leyte Gulf in October 1944. Commander McCampbell, leading a 7-plane division on combat air patrol, received a vector from fighter directors. A large Japanese formation, approximately 60 aircraft, approached the American fleet from the north. 7 Hellcats against 60 enemy aircraft. The mathematics seemed suicidal, but McCampbell understood what Japanese commanders didn't. The Hellcats' firepower, protection, and speed, combined with coordinated tactics, made numerical disadvantage manageable. He led his division into a slashing attack that lasted 90 minutes. McCampbell personally shot down 9 Japanese aircraft. Rushing destroyed 6 more. The remaining Hellcat pilots accounted for additional kills. The Japanese formation, shattered by coordinated attacks it couldn't counter, scattered without reaching the American fleet. McCampbell's gun camera footage shows the execution with clinical clarity. High side passes, zoom climbs back to altitude, another diving attack. The Japanese tried to turn with the Hellcats. The Hellcats refused to turn, maintaining energy and position. When McCampbell landed back on Essex, his F6F had burned through all its ammunition. 2,400 rounds of .50 caliber ammunition, Not a single hit on his aircraft from enemy fire. The tactical dominance was so complete that a single division, properly trained and coordinated, could engage and defeat formations 8 times its size. The evolution to defensive dominance. October 25, 1944. The Battle of Leyte Gulf had cost the Japanese 3 escort carriers and multiple aircraft. More significantly, it had introduced a new horror to Pacific warfare: kamikaze attacks. Japanese pilots deliberately crashing explosive-laden aircraft into American ships. The kamikaze threat changed the tactical equation fundamentally. Against conventional attacks, Hellcats had proven nearly unbeatable. But kamikaze pilots didn't need to survive, didn't need to dogfight, didn't need to evade. They needed only to crash into their targets. A single suicide aircraft penetrating the combat air patrol could cripple or sink a carrier. The Navy turned to the man who had created the defensive tactics that saved American fighters in 1942, Commander John Thach, now serving as operations officer to Vice Admiral John McCain, commander of the Fast Carrier Task Force, received orders to develop a comprehensive defense against kamikaze attacks. Thach approached the problem with the same methodical creativity he'd applied to the Zero threat. Matches on his desk became ships, fighters, and incoming suicide aircraft. He worked through dozens of scenarios, calculating intercept times, patrol patterns, and coordination requirements. The solution he developed would become known as the Big Blue Blanket. The concept was elegance itself. Instead of concentrating Hellcats close to the carriers in immediate defense, Thach proposed a layered defense system extending up to 60 miles from the fleet. Combat air patrols would be larger, positioned farther out, and maintained continuously around the clock. Picket destroyers and destroyer escorts, positioned 50 or more miles from the main body, would provide early radar warning. Fighter director officers on carriers would coordinate defensive fighters using improved radio communications and radar tracking. And critically, Hellcat squadrons would conduct continuous offensive sweeps over Japanese airfields, destroying kamikaze aircraft on the ground before they could launch. The Big Blue Blanket made the Hellcat not just an offensive weapon, but a complete defensive system. The blue-painted F6Fs, constantly overhead, became a symbol of American air superiority. For Japanese pilots, the blanket meant that reaching American ships required penetrating multiple layers of coordinated defense. For American sailors, it meant safety. The system debuted during the Philippines campaign in late 1944. Despite intense kamikaze pressure, American carriers suffered far fewer losses than anticipated. The layered defense intercepted most suicide aircraft before they could reach the fleet. Those that penetrated the outer defense layers faced increasingly desperate circumstances. Hellcats attacking from multiple angles, shipboard anti-aircraft fire, and even if they reached attack range, the small target area of a carrier deck made successful crashes difficult. Lieutenant Eugene Valencia, leading his division in defense of the fleet off Luzon, developed a refinement to the Big Blue Blanket that he called the mowing machine. 4 Hellcats in line abreast, separated by 100 yards, would sweep through Japanese formations at high speed. Each pilot covered his sector. They would make one coordinated pass, climb back to altitude using their superior power, and repeat. Valencia's combat record using this tactic was extraordinary. 23 Japanese aircraft destroyed during the Philippines campaign. His division, working as a coordinated unit, disrupted kamikaze formations before they could organize attacks. The tactic spread through the carrier air groups. By January 1945, every Hellcat squadron practiced mowing machine attacks. The campaign for Okinawa, beginning in April 1945, tested the Big Blue Blanket to its limits. Japan launched 1,900 kamikaze sorties against the American fleet. The assault represented the largest sustained aerial attack in history. The Hellcat force, executing Thach's layered defense combined with Valencia's mowing machine attacks, prevented approximately 80% of kamikaze aircraft from reaching their targets. The statistics from Okinawa defined the Hellcat's complete dominance: 38,000 combat sorties, 2,351 enemy aircraft destroyed, against losses of 249 Hellcats from all causes. The kill ratio, 9.5 to 1, exceeded even the Philippines Sea. Results when adjusted for the desperation of kamikaze tactics. But the numbers don't capture the human reality. Each sortie represented young men, many barely out of high school, climbing into fighters and facing suicide aircraft deliberately trying to kill them. The Hellcats' armor, speed, and firepower kept them alive when earlier fighters would have gotten them killed. The coordinated tactics developed from Thach's Weave gave them a fighting method that made survival possible. The final accounting. By August 1945, when Emperor Hirohito broadcast Japan's surrender, the F6F Hellcat had compiled a combat record unmatched in naval aviation history. 5,223 enemy aircraft destroyed in aerial combat, 270 Hellcats lost to enemy fighters, kill ratio of 19.3 to 1. But the raw statistics only begin to tell the story. The Hellcat produced 305 United States Navy aces, pilots who had destroyed 5 or more enemy aircraft. It accounted for 75% of all Navy air-to-air victories, despite entering service 18 months into the war. It transformed carrier aviation from a defensive gamble to offensive dominance. More significantly, the Hellcat validated Thach's fundamental insight from 1942. Coordinated tactics could overcome individual aircraft performance disadvantages, and coordinated tactics combined with superior aircraft performance created unbeatable dominance. This lesson, learned through bitter combat over the Pacific, would shape air combat doctrine for generations. The Japanese perspective, preserved in post-war interviews and documents, revealed complete tactical and psychological collapse. Lieutenant Saburo Sakai, Japan's legendary ace who survived the war, encountered Hellcats for the first time in June 1944. Despite his experience and skill, he was nearly killed in his first engagement. Sakai's autobiography describes the moment with painful clarity. I performed my best aerobatics, loops, rolls, splits, scissors. Every maneuver I had perfected over 200 combats. The Hellcat followed easily, almost casually. The American pilot didn't try to outturn me. He didn't need to. He used power and coordination with his wingmen. I survived only because the American made an error. He forgot to release his drop tank before combat, which limited his performance. Otherwise, I would have died. By war's end, the pilot crisis in Japanese naval aviation had become catastrophic. Of the 18,000 naval aviators who started the war, fewer than 100 combat-experienced pilots remained. The Hellcat, executing tactics derived from Thach Weave and refined through 30 months of combat, had systematically destroyed the most experienced naval air arm in the world. The transformation from desperation to dominance had taken exactly 3 years. June 1942, Thach executed his defensive weave in inferior Wildcats to avoid annihilation. June 1945, Hellcat pilots executed offensive variations of that same weave to achieve complete air superiority. The fundamental geometry remained constant. The aircraft and training made all the difference. The legacy and the truth. August 15th, 1945, Atsugi Airfield, Japan. The first American aircraft to land after the surrender were 12 F6F Hellcats from USS Yorktown. Japanese pilots, mechanics, and ground crews lined the runway to see their nemesis up close. The reaction, recorded by American observers, was stunned silence. These fighters, which had destroyed Japanese naval aviation, looked almost ordinary sitting on the tarmac, not sleek like the Zero, not elegant like German fighters, just solid, workmanlike, practical American engineering. But when Lieutenant Robert Vasu, an ace with 19 victories, demonstrated the Hellcat's capabilities for the Japanese observers, their silence turned to something else: understanding. Vasu's casual aerobatics, loops and rolls and climbs that would have torn a Zero apart, demonstrated the performance gap that Japanese intelligence had dismissed. "This isn't even pushing it," Vasu told the Japanese pilots through an interpreter. "In combat with water injection, it's 20% more powerful. The plane is stressed for 13 Gs. I've never managed to break one." Professor Jiro Horikoshi, designer of the Zero, studied captured Hellcats extensively after the war. His conclusion, published in his autobiography, captured the complete philosophical difference between American and Japanese fighter design. "We designed an aircraft for 1941. They designed an aircraft system for 1945. While we were perfecting the sword, they were building the industrial age." But the Hellcat's dominance wasn't purely technological. The aircraft's capabilities enabled tactics that Japanese doctrine couldn't counter. The tactics, developed from Thach's original insight, created a fighting method that made individual pilot skill less decisive than coordinated teamwork. The combination was unbeatable. Commander Thach, promoted to captain and then admiral in the post-war Navy, always insisted the Weave was born of desperation, not genius. "We were losing," he told an interviewer in 1970. "The Zero was better than anything we had, so we stopped trying to fight their fight and forced them to fight ours. The Weave was just geometry and cooperation. The Hellcat made that geometry lethal." The tactical revolution that began with matches on a desk in San Diego, tested in desperate combat over Midway, and perfected through the Hellcat's offensive power, became doctrine that shaped air combat for decades. Korea, Vietnam, and every subsequent conflict applied lessons from Thach's innovation. Mutual support over individual heroics, coordinated attacks over single-plane dueling, energy management over turning fights. Modern fighter tactics, with their emphasis on wingman coordination and energy fighting, trace directly to Thach's Weave and its evolution through Hellcat operations. The specific maneuvers have changed. The aircraft have become supersonic and missile-armed, but the fundamental principle remains constant. Two aircraft working together can defeat superior opponents. Superior aircraft executing coordinated tactics become nearly unbeatable. The final testimony came from Admiral Jisaburo Ozawa, who had commanded the Japanese fleet at Philippine Sea. In a 1962 symposium on Pacific air warfare, attended by both American and Japanese veterans, Ozawa provided perhaps the most honest assessment. "We laughed at the Hellcat because we didn't understand it. Represented not just an aircraft but an entire civilization's approach to war. By the time we stopped laughing, our air forces had ceased to exist. The mathematics were undeniable." 19 Japanese aircraft were destroyed for every Hellcat lost in air combat. 12,275 Hellcats produced in 30 months versus approximately 6,000 Zeros produced from 1943 to 1945. Over 5,000 American pilots trained on Hellcats versus fewer than 100 combat-capable Japanese pilots remaining by August 1945. But beyond the numbers lay a human story. The story of one pilot, John Thach, who refused to accept that his inferior fighters couldn't compete and developed tactics that made competition possible. The story of thousands of young American pilots who learned those tactics and executed them with skill and courage. The story of engineers and factory workers who built an aircraft specifically designed to execute those tactics at maximum effectiveness. The F6F Hellcat entered service weighing twice what the Zero weighed, carrying armor the Zero didn't have, powered by an engine the Japanese couldn't build, armed with weapons they couldn't match, guided by radar they couldn't detect, flown by pilots trained to standards they couldn't maintain, produced in numbers they couldn't comprehend. Every extra pound represented not weakness, but the strength of an industrial democracy that could afford to protect its warriors. Every tactical innovation represented flexibility that rigid Japanese doctrine couldn't match. Every coordinated attack represented teamwork that Japanese individualism couldn't counter. The Japanese pilots had dominated Pacific skies for 18 months through superior aircraft and superior tactics. The Americans had learned from desperation, innovated from necessity, and industrialized the solution. Thach's impossible maneuver, born of matches on a desktop and tested in desperate combat, had evolved into a tactical system that destroyed an empire's air power. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.